what we're doing now is we're starting our next unit. And the goal of this unit is I can determine if a function is periodic and I can state the key features of a periodic functions. Okay, so 5.1, periodic functions. So first of all, a periodic function is a function that repeats in a regular way. So we have seen lines and things, but they don't repeat. So it's something that has to repeat. Sometimes I think of it almost like a stencil. And when you think of it like a stencil, you put the stencil down, and you make the pattern, you pick up the stencil, you move it over, you fill it in again. So it's repeating in a regular manner. Now, the reason we study periodic functions is many real life situations model periodic functions. And some of those things include weather patterns. For instance, we know, for instance, in this area that spring comes at a certain time, summer happens at a certain time, and the temperatures within those periods of time are fairly regular from one year to the next, even though we do have what we call global warming that has affected them a tiny bit. Another thing that repeats in a regular way is tidal waves, right? So high tide, low tide. Okay, it happens every 12 hours, high tide, low tide. So again, it happens in a regular manner. Sound waves also repeat in a regular manner. Population cycles, especially if you look at population cycles of animals or even insects for that matter. We know that, for instance, certain insects only come out after so many years, and that's its cycle. Electric current is another reason why we study periodic functions. So there's lots of different jobs that require you to deal with periodic functions. Whether you will do that or not is totally up what your future events will happen in your life. Now, examples, if you notice, there's an example here of a periodic function. So if you notice, if I look at the first one, it starts, sorry, I've got my pen in the right place. It starts here and it goes down, and there it is. But then it repeats itself, that same pattern, and actually I can take it, that same pattern repeats again. So it's like that stencil that I talked about um, earlier. So it just keeps repeating, and then it goes again, and then we would assume that it would go again. It goes on and on and on. Now, it doesn't have to look like this. You could have a periodic function that looks like this. So there's some dips and dives, but again, it's like a stencil and it repeats again. Okay, so it's like the stencil. In this case, the stencil would be here, and then what happens is it repeats itself, and you can see it just keeps on repeating. So there's another one. This one also repeats. It's a funny looking graph in a sense, but it's a periodic function because it does repeat in a regular way. So what we're going to talk now about is terminology. And if you've taken physics, physics also studies um, these types of graphs as well. They use slightly different terminology than what we do in math, but it's very, very similar. So in math, we talk about period. Okay, in physics, they talk about cycle. So it's what we're looking at is we're measuring the horizontal length, sorry about that, horizontal length required before the pattern repeats. So it's like, how long is the stencil? So if I look at here, the period goes from there to there. So this here is the length of the period, because if you notice, if I go and do that, it repeats again the same thing. So this here is the length of the period. Okay, and then the other thing that we talk about amplitude. Now, um, in physics, for instance, they talk about amplitude too, but they talk about crests and troughs. So in physics, they call this the crest and they call this the trough. So in physics, and I'll just put that, so it's they call this the crest and they call this the trough. Now, because in in math, we're studying all different types of waves, all different types of periodic functions. We won't use these terminologies. We talk about the amplitude. And it is half, oops, it is half, go away, half of the vertical measure of the graph. So if you notice there's a line here, so here is the highest point, here is the lowest point, and halfway in between this distance here is what we call the amplitude. So from the top of the graph to the bottom of the graph, we divide it by 2. Okay, so we divide by 2, and that's how come we get, for instance, this is the amplitude. Okay, now I notice if you look at what I have written down here, we talk about absolute value. Absolute value means I don't care if the graph is going up first or whether it's going down first. It's the horizontal distance, the vertical distance here that I'm worried about. And so that's amplitude, the vertical. The horizontal distance or the length of the pattern is what we call the period. Okay, so what we're going to do today is it says state whether the following are periodic. So we're not only are we going to state, we're going to say why it's not periodic or why it is. So if you look at this first one, we can see it's kind of wavy pattern, but then it almost looks like it flatlines. So it doesn't appear that this pattern is repeating itself. There's no indication of this. So this one is not periodic. So we're going to put not. And why would we say it's not? We would say that the pattern does not repeat. Now, if we look at the next one does look, it almost looks like a bouncing ball, but the thing is a bouncing ball wouldn't be periodic either because it's amplitude. You notice it goes up and it goes down, and then if I actually take that, it appears that this is the stencil. Okay, so it's going along and along. So we would say that it is periodic. Now, if I look at the next one again, it's got this highs, lows, highs, lows, highs, lows, high, lows. But the problem is there is some kind of periodic with those spikes. However, the amplitude keeps changing. So we say that it is not. And one of the reasons we're going to say it's not is because the amplitude changes. And it looks like the period changes as well. If you look at this as the length of the period, is different than, for instance, this length. So it's not because of the amplitude changes. Get back there, amplitude and period changes. And then if we look at the next one, since I get the word changes in there, changes. The next one, I would say it is. Okay, I'm just going to start it here, and let's see. If I take that, it repeats in a regular manner. You can see that that's the stencil. It just goes right along there. So this one is periodic. And the next one, we've studied this graph before. This is actually a parabola. And yes, I recognize the parabola, but we don't take the parabola and repeat it. Okay, we draw lots of different kinds of parabolas, but we don't take the same parabola and we don't repeat its pattern. So this one is not. Okay, it is a function. Actually, all of these have been functions. However, this is not, and the reason it does not repeat. All right, so now what we're going to do is we're going to look at an example that is periodic. Okay, and this is it here. And you can see it does repeat itself. And actually, if this is from some data that was collected, the number of daylight hours and the month that it occurs. And obviously this graph is going from zero to 30, almost 36 here. So we're looking at 3 years worth of data that's been collected, and this is what they have. And for the most part, it looks like it is periodic. So the first thing it asked me, what is the period? So remember, that's the length of the stencil if you want to think about it. Now, obviously it starts here and it's very hard to tell exactly what that number is. So I can go anywhere on the graph where it's easy. So I'm thinking that I can see, and I can see there's the other spot where it reaches. So it's easier for me to read this line here, the distance, because that distance, if I take it, it's going to, well, kind of. I'm just going to lock that in place. Oops, didn't do it. That repeats itself. If you notice, that looks pretty close if this came down. Okay, so it looks like that is the length of the period. So from 12 months to 24 months. Okay, what's the distance in between there? Well, it's 12. So we're going to go back up here and we're going to say the period equals 12. Okay, now the amplitude. Well, it appears that if I go over here, it's about, I don't know, we'll say about 15.5. And down below, it appears that it's at 9. Okay, so the distance between there for the amplitude is, and I'm just going to take it over here, is we're going to take the 15.5, we're going to subtract our 9, so now we're at 6.5, okay, and then we need half of that number. So if I take that number and divide it by 2, we end up with our amplitude equaling 3.25. Okay, so it's the distance, the vertical distance, half of it. The domain, we did this from our first unit, and it has to do with the x-axis. So the domain for this graph is, it appears from 0 to 33. Okay, so our domain is, and I guess we'll talk about x is going to fit between 0 and 33. Now, does it go on forever and ever? Yes, it actually does. So in a sense, what we could do, this also would be acceptable if you put x, let's do this, x is greater than or equal to 0. Okay, because time does go on and we assume that this graph will continue. Now the range has to do again with the vertical. Now if you notice, we already picked out the lowest point was 9, the highest point was 5.5. So that means our y has to fit between the lowest point and the highest point. Okay, so it has to fit between 9 and 15.5. So it fits in between there. Okay, so kind of reviewing domain and range from our first unit. Okay, kind of what's different is period and amplitude. Now there's a few questions in the textbook for you to do, some of them asking for different things in regards to whether something's periodic, as well as doing a question something like this. Have some fun.